the ODE, ordinary differential equation. So we got dy over dt plus 1 over ty equals cosine t, and it's given that t is positive. So here y is the dependent variable and t is the independent variable. So whenever we have, let's say, dy over dx plus pxy equals qx, so y is the dependent variable, x is independent variable, and the coefficients px, qx, there can be something, but we can always divide through by that. If that is a function of independent variable, so in this case x, then this is called a linear differential equation. And to solve, we find the integrating factor. Okay, the integrating factor is e raised to integral of this function. Okay, integrating factor. So we have this ODE exactly in this form. So y is the dependent variable, t is independent variable, 1 over t, so y prime, and this coefficient and this, they are functions of independent variable t. Okay, so this is linear. So we can say this is a linear ordinary differential equation. To solve, we find integrating factor. Integrating factor mu is a function of t in this case, and this is our pt. So it's a px, but we got pt 1 over t. So mu t is integral e raised to integral of this, which is 1 over t dt. That is e raised to antiderivative of, it's like 1 over x dx. That's natural log of x, absolute t. But t is positive, so we don't need absolute value here. They cancel. E and natural log cancel, just t. Now we multiply this ODE, the given ODE, by the integrating factor. Then star becomes, after multiplying both sides by the integrating factor t, the left hand side will be derivative of the dependent variable times the integrating factor, which is t. So that will be automatic, equals, let's multiply right hand side by the integrating factor, so t and cosine t, just t cosine t. Okay, the left hand side is just automatic. When we multiply this linear ODE by integrating factor, the left hand side will be automatically derivative of dependent variable times integrating factor, whatever we have. Okay, that's the case. Now we want to integrate both sides with respect to t, the independent variable in this case. So integrate with respect to t, so we got y times t, integrate with respect to t times cosine t dt. Now we need to integrate this right hand side and finally isolate y by dividing both sides by this t, integrating factor. Okay, but this is a product. That means to integrate, we need to use the integration by parts. The integration by parts, what is that? So when we have u dv form, then when we integrate, that is uv minus integral v du. Okay, and as a algebraic function, that is, this is like our u and everything else is v dv. So we have in this form, and then this is how we finish this problem. Okay, so let me just do this portion in the right side so that it's easier. I don't have to copy the left side. So for t times cosine t dt, so we let u be t and dv be the rest, cosine t dt. we need to find du, derivative of u with respect to t, du over dt, by the way, 1 and dt on the right side, integrate with respect to t, so v equals sine t. Then this one is then uv, so this one, okay, not integral, just uv. So I was trying to erase, okay, uv, so this integral equals uv, so t times sine t minus, okay, I'm applying this formula just the right side, uv minus integral v times du, so sine t times 1 dt, just dt, so this is t sine t minus antiderivative of sine is negative cosine plus c, this minus in negative plus, so I'm going to write this over here. So we have y times t in the left equals, this integral is here, t sine t plus cosine t plus c. Now we divide both sides by t to isolate y, thus y equals divide by t, so we got 3 terms, so we need to divide separately, t sine t over t, just sine t plus cosine t over t, so there is nothing we can do, just write down cosine t over t, okay, this is a function, is another function, plus c constant over t, final.